Okay, then it's my part. It's Longfei, and my name is Longfei, and works in CST since 2015. And basically, I work as an EDA expert, and in CST. And today, I would like to talk about on the high-speed backplane systems. And I think it's a hot topic, especially for the faster development of the Ethernet network. And here, let's go to the first slide. And we have we simulated in this work a 1 meter long backplane with a baud rate of 28 gigasymbol per second, and also with PAM4 modulation. And we use a DFE and FE equalizer to reach a beta rate of 3.5 E-5. And error propagation effect is also modeled by Markov chain, is also considered. And also we estimated the beta rate after forward error correction. And this technique is also almost mandatory for this high-speed interconnect, because the channel is so long and data is so high. And we have to use FEC to reach the beta rate in the range of E-14. And also we present a new workflow to simulate the step response for the SerDes channel. And previously, in comparison to the traditional workflow, which use S-bar meter and the macro modeling, we don't simulate the S-bar meter. In this case, we solve a Maxwell equation and the circuit equation in time domain and get the step response directly. And in the end, we will show some capabilities of CST AMI task. And this task is implemented in the year of 2019, and to show you some CST IBC-AMI simulation capabilities. Okay, then let's go to the outlines of my presentation. The first part I will give a short introduction of the backplane system, and then in the second part I will do some pre-layout analysis to show some important factor that you need to consider for the layout or the routing of the SerDes passive interconnect. And the third part I will show you the true channel simulation and compare it to the traditional workflow. And in the fourth part, I will do some forward error correction analysis with the consideration of error propagation effect. And in the fifth part, I will show CST AMI task and show you some AMI simulation capabilities of CST. And then in the last part, I will give a short summary. And here's the workflow of this presentation. And actually, currently AMI cannot handle FEC for the error correction analysis, and it cannot model the error propagation effect. So you have to do some programming work and signal processing work in MATLAB or in Python, or I did it in the VBA integrated on CST platform, which is quite nice, and we can have a look later together. And so we don't use AMI simulation in this case, but you can use it, and we do the equalization and the random jitter with CST eye diagram tool. So we will look into the details later. Okay. And yeah, there's some introduction. I mean, some note for this for the following slides. I mean, all the slides will be marked with X, A, B, C, D, E, F, and they are corresponding to different models. If you're interested in model, we can send it to you, and you know the result corresponding to which model. And also some slides marked with the software info that show you where to find the CST buttons and functions. Okay, let's go to have a look at part one. And here's the backplane system of in the Ethernet, for example. And it basically contains transmitter, receiver, and daughter board, motherboard, and also connectors. And the backplane we simulated here is about 1 meter long, 600 millimeter for motherboard, and 250 millimeter for a daughter board. And also there are some very rough, simple connectors that we draw in CST, we design in CST, and to connect the daughter